Lesson 8.1, Similarity in Right Triangles. The objectives for the lesson are to use the geometric mean to find segment lengths in right triangles, apply similarity relationships in right triangles to solve problems. The vocabulary word you need to know is geometric mean. The geometric mean of two positive numbers is the positive square root of their product. So the geometric mean of A and B is the positive number x such that x equals the square root of A times B, or x squared equals AB. In a right triangle, we know the altitude is drawn from a vertex of the right triangle to the hypotenuse. It forms two right triangles. This gives us Theorem 8.1.1. The altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. When looking at these, we will want to make sure that we match up the vertices of the three triangles properly. So we have triangle ABC. So ABC is similar to ACD, which is also similar to CBD. In each case, we have named the right angle, as the last angle of our triangle. Let's look at an example. If we want to write a similarity statement comparing the three triangles, and we have triangle UVW, sketch the three triangles with the angles of the triangles in corresponding positions. So start with your large triangle, and let's just swing it down so that U is on the left and the right angle is on the right-hand side at the bottom. And then we look at the next one, and we have U and Z, and W is at the top. So you've kind of flipped it over so that this side is the right angle and it's at the bottom. And the last one then is WVZ. So WVZ. Then we can write by Theorem 8.1.1, triangle UVW is similar to UWZ, which is similar to WVZ. If we want to consider proportions, so that A over X equals X over B, in this case the means of the proportion are the same number, and the number that is the geometric mean of the extremes. Okay. The geometric mean, as we said, of two positive numbers is the positive square root of their product, so that we either have X equals the square root of AB or X squared equals AB. Using an example, let's find a geometric mean. It says find the geometric mean of each pair of numbers. If necessary, give the answer in simplest radical form. So in other words, I don't want you to use a calculator for these. I want you to be using simplification. So our numbers are 4 and 25. So let X be the geometric mean. Then by definition of geometric mean, X squared equals 4 times 25, which is 100. Find the positive square root, and X equals 10. This was nice because they gave us pretty numbers that had a perfect square root. Well, let's find the geometric mean now of 5 and 30. Let X be the geometric mean. Then by the definition, X squared equals 5 times 30, which is 150. Well, 150 is not a perfect square, so we have to reduce that. Find the positive square root. X equals the square root of 150, which is 5 square roots of 6. Remember that you are finding the factors of 150, and if you can circle a pair that matches, they go outside on a date, so we had 2 5s, and we had 6 left over. We would have underlined the 6 because it stays home by itself. You can use the Theorem 811 to write proportions comparing the side lengths of the triangles formed by the altitude to the hypotenuse, and all the relationships in red involve geometric means. We have large triangle ABC. We have also a triangle where we have dropped the altitude CD, so we have ACD. We also have CBD. So B over A is equal to Y over the altitude, which equals H over X. It is similar to the other triangle here, so that C over A is equal to B over H, which equals A over X. And for the smallest triangle that we have made, we have C over B is equal to B over Y, which equals A over H. This brings us to two corollaries, the geometric means corollaries. The length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So we have h squared equals xy in this case. So we're looking at the altitude, and the two lengths of the hypotenuse that we cut times each other equals h squared. So this is a special ratio. The length of a leg of a right triangle is the geometric mean to the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg, which is a lot of words, meaning if we look at our small triangle here, a squared equals x times c. So the entire hypotenuse of the big triangle times the piece that is adjacent to the side we're talking about. Just like b squared is equal to y times the entire hypotenuse c. For example, if we want to find x, y, and z in this triangle, we know that 6 is the geometric mean of 9 and x. So we have our altitude, and it equals the two pieces of the hypotenuse multiplied. So 6 squared equals 9x. Divide both sides by 9, and x equals 4. For y is the geometric mean of 4 and 13. Okay. Since x is 4, and we add 4 plus 9, we get 13. That's the entire hypotenuse. So we have y squared equals 4 times 13, which is 52. And then we find the positive square root, and y equals 2 square roots of 13. Z is the geometric mean of 9 and 13. Remember, the whole length is 9. So we have z squared equals 9 times 13, which is 117. Find the positive square root, and this is 3 square roots of 13. Once you've found the unknown side lengths, you can use the Pythagorean theorem to check your answers. Let's look at another example, a measurement application. To estimate the height of a Douglas fir, Jan positions herself so that her lines of sight to the top and bottom of the tree form a 90-degree angle. Her eyes are about 1.6 meters above the ground, and she is standing 7.8 meters from the tree. What is the height of the tree to the nearest meter? Well, let's let x be the height of the tree above the eye level. So we're talking about this piece of the hypotenuse. 7.8 is the geometric mean of 1.6 and x. So 7.8 squared equals 1.6 times x. We're going to solve for x and round. And x equals 38.025, which is about 38. The tree is about 38 plus 1.6, which would be 39.6, or about 40 meters tall. Now you try. Make sure you answer these questions showing your work and place them in your folder for credit, and label them You Try 8.1. There is a second page.